Okay, so in this video I'm going to be showing you how when a host A sends the data to host B, how is the data broken down while it is going from host A to host B. See, if I send the data from host A to host B, they should be following this TCP IP protocols. Then only I can send the data. If they do not follow this protocol, if both the hosts do not follow this protocol, then we are unable to send the data. So it's necessary for both the hosts to follow this protocol. So see, host A also has 5 layers. Okay, host A has 5 layers. The what are the layers? Let me see. The first layer is application layer, right? What is the second layer? The second layer is transport layer. Okay, what is the third layer? The third layer is obviously the network layer or the internet layer, whatever you call this. The next layer is the data link layer. Okay, and the final layer is the physical layer, right? So this thing also is present in host B, right? Let me draw this for you guys. Okay, wait. Yeah, so all these 5 layers are present in both the host as well as the host A as well as host B, obviously. So let me just do this. Yeah, now what happens, let's say a host is sending some sort of message to host B. So what is actually happening? So the first layer is the application layer. So the application layer just doesn't break the data. Application layer has the message itself. Okay, it doesn't break the data or the message, anything. Okay, now when the message gets enters into the transport layer, what does the transport layer does? It divides this message into segments. What does the transport layer do? It divides the message into segments. Okay, some smaller segments. So the size of each segment is less than 1460 bytes or equal to 1460 bytes. Okay, let me write it like this. Segments, the message get divided into segments, and size of each segment is from 0 to 1460 bytes. Okay, this is the size of each segment. No segment can be greater than 1460 byte. Okay, so this is the segment. Now next, when the data enters from the transport layer to the network layer, what happens? The network layer divides these segments into packets. Okay, the data gets divided, all these segments gets divided into packets. Okay, and then when the data enters from the network layer into the data link layer, all the packets are then converted into frames. Okay, and then when the data enters from the data link layer to the physical layer, all these frames get converted into the signals, and this is the raw form of the data, and these signals get transmitted from the host A to the host B like this. Okay, signals can be transmitted like this, or these are digital signals, so I think this will be transmitted something like this. Okay, so this gets transmitted to this host, and what happens in the host B part or to the receiver part, the physical layer first of all receives all these signals, and then it converts those signals into frames when it reaches the data link layer, and then these frames get converted into packets when they reach the network layer, and these data packets get converted into segments when they reach the transport layer, and finally these segments get converted into the actual message that was sent by the sender. Okay, so that's how a message or a data is sent from the sender to the receiver. Now how now let us observe the internal functionality of each layer. So see what is happening in the transport layer, it gets divided into segments. Okay, so see, let's see the job of the transport layer. Okay, so this is the basic overview. Without this you can't understand computer networks at all. So see what happens, the transport layer, what does the transport layer do? It divides the entire message into segments. Okay, so right, so let's say this is the entire message. Okay, this is the entire message. It gets divided into segments. Let's say this is the first segment, this is S1, then this is the second segment, this is S2, this is the third segment, this is S3, and let's assume this is the fourth segment, this is S4. So what extra is added to each segment? Okay, the size of each segment is 0 to 1460 bytes. I think you guys know 0 to 1460 bytes. The same is for this one, 0 to 1460 bytes, and this 0 to 1460 bytes. So what extra is added to this segment? So a TCP header, okay, a TCP header is added to each segment. Okay, a TCP header is added to each segment. We will be further talking about the TCP header later as we cover the chapter, but for the timing, just understand to each segment what is added. An extra TCP header is added, which makes the size of the segment less than or equal to 1460 bytes. Okay, so that's the main thing. Now when these segments get passed down, these segments gets passed down to where? This segment gets passed down to the network layer, right? If I'm not wrong, these segments get passed down to which layer? These segments get passed down to the network layer. Now when the network layer receives these segments, it divides each segment into smaller packets. Now let's see the functionality of the network layer. Okay, so this is also important. Okay, so whenever the network layer receives the segments, it divides each segment into a packet. Okay, so see, let's say this is one segment. Let's say this is the first segment which is reached to the network layer. So what does the network layer do? It divides this segment into packets. Okay, this segment is divided into further packets. So let's say this is the first packet, this is packet 1, this is the second packet, this is packet 2, this is the third packet, this is packet 3, and this is the fourth packet, this is P4. Okay, now after dividing the segment into packets, what does it extra do? It adds the IPv4 header. Okay, okay, wait a second. I'm not gonna be saying that it adds only the IPv4 header, it can add the IPv6 header as well. So I will just say it adds the IP address header. Okay, with each packet, it what does it add? It adds the IP address header. Okay, so this is the IP address. It can be IPv4 version 4 IP address or IPv6. So it can add anything. I'm not concerned about that. Okay, so just with every packet it adds an IP header. So this is what is added. Okay, so we will be studying about IPv4 header further when we cover this chapter, but for the timing just know that all the packets are attached with an IP header. Okay, so IP header contains what? The source address, the destination's IP address, the time to leave field, the checksum for checking whether the packets are error free or not. So there are many things inside the IP header. So those are the things. Okay, now after assigning the IP header to each of the packets, what is done next? All these packets get transferred into the layer which is beneath. What is the layer beneath? The next layer is the data link layer, right? If I'm not wrong, yeah. So the next layer is the data link layer. All the packets get transferred into the data link layer. Now let's see what is happening in the data link layer. So data link layer, let's see the functionality of the data link layer. What is the data link layer doing? Okay, now what happens in the data link layer? When the packets reach the data link layer, the data link layer divides each packet into a collection of frames. So let's see this packet. Okay, let's say the packet 1 has arrived. All the packets will be arriving, but we will be just observing one packet because all the packets will be treated the same way this packet is getting treated. So don't worry about that. Let's say packet 1 has arrived in the data link layer. So what will happen? This data packet will be divided into frames. So this is frame 1. Oh, this is the first frame. Let's say this is the second frame, this is the third frame, and this is the fourth frame. Okay, so the packets are, and there will be much more frames, but I'm not concerned about that. There will be many frames, there can be many frames, but actually what is happening, the packets are getting divided into frames. All the packets are getting divided into frames. And what is the data link layer doing extra? So the data link layer is adding a header field and a trailer field to each of the frames. To each of the frames, it is doing what? It is adding a header field and a trailer field. Okay, so like this thing is happening to every frame. Okay, like that. Now what is there in this header field and trailer field? So it has many things. When we will be studying about this header and trailer field, okay, we will be learning more about these things, but for the time being, just understand these are the things that are present in the data link layer. So well, let me tell you what contains in this header part. So it contains the MAC address of the source, the MAC address of the destination. Okay, then it also contains what type of frame it is. There are two types of frame, you can say. That one is the Ethernet frame, another is the Wi-Fi frame, where Ethernet is a standard. So that is the thing. Source MAC address, destinations MAC address are present in this data link layer, and source IP address and destinations IP address are present in the network layer. It also tells what type of frame it is, whether it is Ethernet frame or it's a Wi-Fi frame. So type of the frame is also we get through that, and also it has some error correcting mechanisms, right? So all of these things are present in this header part and trailer part. When we will study more, we will be seeing those things, don't worry. And now all of these frames along with their respective header and trailers are transferred into where? Are transferred into the layer which is called the physical layer. Are transferred into the layer which is called the physical layer. Okay, now let's see the functionality of the physical layer. Okay, so let's see what happens when these frames reach the physical layer. So see, when these frames reach the physical layer, let's consider only one frame that reaches the physical layer. I mean, all the frames will reach the physical layer, but we are not concerned about all the frames because everyone will be treated the same. Let's check one frame which reaches the physical layer. Let's say frame 1 reaches the physical layer. So it has two things. One is the header part and one is the trailer part. So this is the frame. Okay, this entire frame is obviously it has a particular size, so the header length has something, the frame has something, the trailer has something. Okay, so we are not bothered about what is inside, just we are know that there is something which is inside all of this header, frame and trailer. There will be some data, there will be some header parts, some header files, some trailer files, some checking mechanism, everything will be there. So we will be converting everything into binary. Okay, we will be converting everything into binary. So let's say someone might ask what will can be the size of one frame. So it depends on which protocol you are using, okay, or which technology you are using. If you are using Ethernet technology, okay, then the typical size of a frame can be 15-18 bytes. Okay, so if you are using Ethernet, then the size of this frame can be 15-18 bytes. Okay, if you are using Wi-Fi, okay, it gives a bigger amount of frame. If you are using Wi-Fi, then the size of the frame, okay, then the size of this same frame can be 2 3 4 6 bytes. So you have to keep this in mind. So if you are using Wi-Fi, then the size of the frame is 2 3 4 6 bytes. So you have to convert every bytes into bits, and then it converts into binary. For example, this I am not considering this one. Let's say, for example, assume that the size of the frame is 32 bits. Okay, for example, let's assume the size of the frame is 32 bits. Okay, so 32 bits means what? Okay, so 32 bits means what? So let's say there are 5 ones means 32, right? So 1 1 1 1 1. Okay, so how is this going to get transmitted? So let's say it's something like this. It's something like this. So 1, then 2, then 3, then 4, then 5, and then down, and like that. So this is the positive side. So this is the actual frame that is getting transmitted in the form of signal, and this reaches the receiver side. Okay, and then receiver just decodes it and finds out the entire components that are present in each frame. And then what happens in the physical receiver side? Okay, let's see. When the receiver receives that signal in the physical layer, it converts those signals into frames, and then it gets various amount of frames, and then it combines all those frames and forms various packets, and then it again combines all those packets and form various segments. Okay, and then finally it converts all the segments and finally formulates the message which was sent by the sender. So actually these are happening, but we are just considering the overview of what the hell is happening over here, and in the next video we will be covering in more details so that you understand what is exactly happening. So from the next video we will be starting the data link layer. Okay, so thank you for watching.